This video is an official guide for the operation procedure of Qlight's IO-Link products. Introduction to Qlight's IO-Link products. Hello. In this video, we will introduce the key functions and IO-Link installation method of Qlight's new IO-Link product series, focusing on the QDT50LIOL model. Let's first visit the Qlight website to view the 3 IO-Link models. Let's start by checking out these products on Qlight's official website. Once you're on the website, navigate to Smart Factory and click on IO-Link product. There you'll find detailed information about all 3 IO-Link models. Downloading the IODD file. To use IO-Link products, the first step is to download the IODD file. IODD files are available both on the Qlight website and the IO-Link Consortium website. Let's first look at how to download it from Qlight's site. Go to the product detail page, scroll down, and click the IODD file download button. You can also download the file from the IO-Link Consortium website. Click on the IODD Finder menu on the right-hand side. Search for Qlight, and you'll see a list of IODD files by product. Select the file for your device and download it. Connecting the IO-Link master. Any IO-Link master that supports IODD version 1.1 can be used, regardless of the manufacturer. However, the master's control software may differ depending on the brand, so please refer to the respective user manual. In this video, we'll use an IO-Link master from Autonix to demonstrate the connection process. Start by powering on the IO-Link master. Next, connect the Qlight IO-Link device using a cable. Use an M12 connector to complete the connection between the device and the master. Finally, connect the master to a PC with a USB cable so you can control the device from your computer. Running the PC software and registering the master. Launch the IO-Link Master PC software that was installed earlier and click Add Master. Click the Refresh button under the Serial Port section to view the COM ports. Select the appropriate port and click Connection. Once connected, 8 ports will appear on screen, numbered 0 through 7. In this demonstration, the Qlight IO-Link device is connected to port 0. In the program's CQ mode, select IO-Link Auto Start. Click Connect Device to link the downloaded IODD file. Click Import IODD file, then open the correct file for the sample model, QDT50LIOBZ, 5-step 24 volts. Once the file is imported successfully, the product name will be displayed as a folder. Click Apply, and if the connection is established correctly, you'll see the Operate status. Operate indicates that the master and the IO-Link device are currently connected properly. Program menu structure. Since the product is connected to port 0, selecting port 0 will display information such as vendor name, vendor ID, and device ID. Scrolling further down, you can also check the M12 connector pin map according to the connection type. At the top of the program, you'll see 2 tabs, Parameters and Process Data. The Parameters tab is where you configure the device functions, and Process Data is where you send the data to operate those functions. Let's first look into the parameters. In the Parameters tab, you'll find Setup and Configuration Color. Setup allows you to define how the device operates. You can choose from External Trigger, Segment Mode, Level Mode, or Demo Mode. Under Configuration Color, you can assign up to 8 different colors. Color 0 is typically used for off. Colors 1 through 7 can be assigned using RGB percentages to control brightness. For example, if you set color 1 to red 100, the red light will turn on. Setting red to 0 and green to 100 will light up in green. Default values include green for color 2, yellow for color 3, and blue for color 4. Once you've completed your settings, click Write for each color to apply them. If you set a color for 001, make sure to click Write to finalize it. Setting up external trigger. To configure external trigger mode, you first need to check the pin map. This information is available in the device details. Supply power to wires 1 and 3 and apply VCC to wires 2, 4, and 5 to activate external trigger operation. Once external trigger is set through IO-Link, you can run the product independently without further IO-Link communication, simply by supplying external power. Now let's configure external trigger and observe how it works. Click External Trigger and then Write to complete the setup. Operating external trigger mode. External trigger operates through standard external contact input. We'll use a test jig to demonstrate how it works. First, apply DC 24 volts to the jig. This cable has been prepared with the outer jacket removed so it can connect externally to the M12 connector. Let's connect the device. For external trigger, you'll need to connect 2 power lines and 3 trigger contacts. Connect the ground and VCC lines as shown on the screen. Now connect trigger 1, 2, and 3. Once power is supplied, we've attached switches to operate each trigger. Switch trigger 1, 2, 3. Let's test the operation of the 3 contacts. Power is turned on, and when the contacts are triggered, VCC is supplied to each of them. Trigger 1 turns on red, as configured. Trigger 2 lights up green. Trigger 3 activates red, along with the buzzer. In total, 7 different operations can be verified using these contacts. As you can see, this is a contact-based control method that does not rely on IO-Link communication. Operating segment mode. Segment mode allows individual control of each segment. In this example, the 5-step tower lamp consists of 5 separate segments. This means each step can be controlled independently in segment mode. Select Segment Mode from the Setup tab and click Write. You'll need to configure the segment mode parameters. Setting the segment value to 5 means each of the 5 segments is controlled individually, while setting it to 1 controls all segments as a single unit. The intensity setting adjusts the brightness. We've set the intensity to 100. Dynamic mode can be set to either cycling or flashing. Let's go with a 5-step setup, just like the model. In the Process Data tab, you'll see 5 segments and 1 buzzer. LED behavior can be static for steady light or dynamic for blinking. Let's set segment 1 to red. When only segment 1 is configured, you'll see just the first tier of the tower lamp light up. Now continue setting colors for the remaining segments. Set the buzzer to intermittent slow to begin with. There's also an intermittent fast buzzer setting. Next, let's change segment 2's mode from static to dynamic. Now go back to parameters and change segment 1's blinking from cycling to flashing. You'll notice how this differs from standard flashing behavior. Segment 2 continues in cycling mode, while segment 1 uses flashing. If you change the number of segments setting from 5 to 1, all 5 segments will operate as a single unit. That wraps up our demonstration of segment mode. Operating level mode. Let's now move on to level mode. Select Level Mode from the Setup tab and click Write. In Parameters, configure how the LED display behaves when operating in level mode. You can choose whether the lighting progresses from bottom to top or top to bottom. The segments increasing mode lights up segments one by one, while segments moving makes a single segment move through the levels. Cycling and flashing determine how both active and inactive segments blink. Now let's move on to process data. Set the analog value to 40%, choose red as the color, and apply the settings. You'll see the first two segments light up. Setting the analog value to 60% lights up more segments. If you switch to the moving mode, a single segment will move to represent the 60% value. That completes the configuration of the active area. Next, let's configure the inactive area. Segments that are not lit are considered inactive. Set the inactive color to yellow. Then, set the active brightness to 100 and the inactive segment to 20. This results in a dim yellow glow for the background. Lowering the analog value to 40% reduces the number of active segments from 3 to 2. Now switch the active area's blinking mode to flashing. This shows how you can apply either cycling or flashing to active segments. Inactive segments can also use one of two dynamic effects. That concludes the explanation of level mode. Operating demo mode. Now let's take a look at the demo mode. In the Setup tab, select Demo Mode and click Write. Demo mode sequentially demonstrates the main functions that the IO-Link product can perform. Please note that this mode is set by the manufacturer and cannot be modified. This mode does not require manual configuration in the Process Data tab. Just enabling demo mode will initiate a built-in demo sequence. As shown, the tower lamp will display a variety of lighting colors, blinking patterns, and buzzer sounds. This makes it easy to showcase the full functionality of the product. That concludes our overview of demo mode. For more information on Qlight IO-Link products, please refer to the catalog and manual on the Qlight website.